My name's Roger Quesnel. I'm with, I kind of have two hats as it relates to this presentation. I'm with SkyFoundry and the COO for SkyFoundry. We sell some analytical software. I know there's some of you in here that are familiar faces, so some of us know our product called SkySpark. I also am a board member of Project Haystack, which is a nonprofit organization that'll be part of the third part of my presentation. So I'm going to cover kind of three areas. We're going to talk about data in the built environment and the importance of it and how it can be used. So for some people, it'll be old news. For some of you, it might be not so new. It might be new for some others. We're going to talk a little bit about Project Haystack, right? And well, secondly, we're going to talk about IDL. Some of you may have heard the term integrated independent data layer. Talk a little bit about the conceptions, how people think about it, how we might not think exactly the same way. But and if you've never heard of the term, it's okay. But we'll just talk about the kind of the underlying key components and features of what it represents for a building. And then finally, I'll wrap up with talking about Haystack and some of the initiatives that are going on there, including a pretty exciting Department of Energy project that's been funded by the Department of Energy. So we'll talk a little bit about how it fits in with some of the visions that the Department of Energy have. All right, so unifying data from diverse systems and sources to enable whole building analytics, fault detection, and KPI analysis. KPI meaning key performance indicators. What is it that you're trying to track? What is it you're trying to accomplish? All right, so the role of data analytics and whole building analytics, data is fundamental for commissioning, energy analysis, energy management, monitoring, verification. The sources of data is an ever-increasing avenue for adding value to a building and a project, right? So some of the sources include smart meters, APIs, could be enterprise level data, it could be other applications, data loggers, tariff rate data, weather, and more. And how does this all fit together? We'll talk a little bit more about that soon. There's more data available than humans can deal with manually. So the need for automation and more reuse is very critical. So we need tools. And analytic software is that tool. Right? So we want to transform equipment, sensor, and energy data into value. Data by itself isn't that valuable until you transform it and it becomes actionable information. So examples, detecting faults in equipment operations, simultaneous heating and cooling. I'm not going to cover all these points, right? You have access to the entire slide. Calculating KPIs. What's going on in my buildings over time? Maybe I set in a baseline and I'm going to measure my performance against my goals. What's happened last year? What's happening across different buildings? Correlating energy use with equipment operations, facility use patterns, detecting patterns and trends in energy and other equipment. So detecting patterns in equipment, patterns can be faults in equipment operation, but they can also be trends, predictive of a future fault, anomaly, or correlation. What is the pattern or trend or phenomena you're trying to be aware of? So it's a whole lot easier to set those rules and say, hey, I want to know when X, Y, and Z happens. So anything that you can kind of describe or write mathematically, you can verbalize it. There's tools out there to allow you to notify you when it's happened or potentially when it's going to happen. And you can combine data from diverse systems and devices to identify correlation relationships. So one equipment and another equipment might have something. Maybe there's a weather pattern that impacts the equipment or some event that you want to be aware of. In the end, there are patterns in the data that represent things that matter, right? And they're all different in all buildings. So while there's a lot of reuse, there's always a little bit of customization or a little bit domain knowledge that you guys can bring to the table, right? So if there's different verticals, K through 12 might be different than a sports arena, which might be different than a retail outlet. So those are the things that folks that are experts in those particular verticals can apply and leverage. So rules can be defined to look for patterns. All right, so there's a white paper out from the Department of Energy that talks about monitoring-based commissioning offers benefit at every stage of performance contracting. So for those of you that are interested or either currently doing it or interested in going down the performance contracting avenue, I encourage you to do a Google search on this. A lot of information. So they talk about through the preliminary assessment phase, the investment grade audit, construction and commissioning and performance period. So data is critical and valuable throughout the whole performance contract. All right, here's a set of links to specific monitoring-based commissioning case studies that are on our website that you can look. And so all these come from users out there, right? So we've got some pretty interesting case studies, and you're going to say, how does this relate to this one? There is a virtually unlimited number of use cases that we see out there in the wild. So we have, so SkySpark, our software, is in over 2 billion square feet of facility space, over 20,000 buildings. We're in, if not 100 countries, pretty close to that. And obviously the US is a core market for us. All right, fault detection, visualization of fault patterns. You don't want to have to, you need to take all your CSV files and your data, and you want to be able to visualize them, right? Picture's worth 1,000 words. So when you're looking for a tool, you want to be able to make sure that the visualization sort of comes out of the package, and you don't have to sit there and have your intern or the new college grad sit there and take his Excel spreadsheet and create graph after graph after graph, and then when the data gets updated, they have to you want to be automatic and be presented the way you want. So correlating data from diverse sources. A key function with analytics software is the ability to combine and harmonize and correlate data from different sources, right? You want to be able to combine occupancy sensors with lighting. You want to be able to pull tariff rate information or meter data along with your energy consumption, and able to see relationships that are not apparent by looking at individual systems. Enable analytic algorithms and patterns to be performed across data in diverse systems, detects, exposes correlations and potential causes, right? So it's helpful, patterns detected, and then you could provide some information for the operator to say, when this occurs, maybe these are 3 or 4 things you want to be looking for in that data, right? Whether it's for a customer or if it's within your own organization. And we're going to look at some examples, right? So we want to combine energy and weather data. Be nice to be able to correlate and sort of say, there's something that happened different in Boston during the winter than Dallas during the summer, right? It's going to have an impact on the weather. So you can't just compare. You don't always want to just compare the raw data. Sometimes you need to normalize the data, and so this is often helpful. So you'll see, you can see the yellow bar represents a spark or a detection, some flag for the user, and you can see it's correlated to the increase in temperature, right? So combining energy and weather data for regression analysis. So, okay, let's see if there's a relationship that exists. It looks like it visually, but let's use some analytics to determine if it exists. Energy analysis and reporting. All right, great. So now I need to report on it, and that reporting comes in a variety of formats, right? So you want to normalize for factors such as weather, occupancy, and production activity. What if you got retail outlets and one location sales volume is 3 times the volume of something else, and you know that the energy consumption is going to be somewhat correlated to production. So you might want to normalize that. So the ability to have that automatically done on the fly is enormously powerful. Benchmarking performance across portfolio or with industry standards. Wouldn't it be nice to have, your entire customer base, let's say it's 100, 300 customers, and you want to evaluate them and benchmark them across each other, run some kind of detection tool. You can run that across using a single tool and look at and compare all those different implementations. And then you want to be able to report back, whether that's internal reporting or to the customer, right? Maybe you have a service business that you're providing monthly updates and information, and hey, we just want to, it's nice to have recurring revenue, it's nice to have sticky customers. When you're there and you have the ability to continue to provide ongoing insight and information to the customer, you've got a lifelong customer. Combining energy use data with tariff rates, right? So you can see that real-time energy consumption combined with, and the coloration says, hey, this is what's driving, you're going to hit, this is what's driving your energy costs. So if you can figure out why that 2% of the time you're hitting your ratchet and all of a sudden it has a huge impact on your cost structure, you can take that and then you can even drill down from a particular instance, say, so why is this? Okay, we're not doing any soft starts. We got everything slamming on at the same time, and all we have to do, now that we know what's driving our, a huge portion of our costs, right? Sometimes 2-3% of the time might drive 50% or 30% of your cost. It's a very difficult task to try to answer that question unless you've got a tool that allows you to see and has transparency. Combining energy with tariff use, right? So you end up paying more using less energy. You can use the same amount of energy and pay less. For most facilities, you're at fixed costs, 12 cents per kW. Electric costs are calculated based on complex tariff rates. Using the engine enables you to calculate real energy costs. Like what exactly is driving your costs? And there's not many, this is an enormously powerful tool for people. Combining energy use data with tariffs provides true insight into financial impacts. You can assign a cost component, right? And so you can say, look, I hear your operations guy saying, we need to do this because X, Y, Z. But then if you got the financial guy and say, well, you realize because you've got this one tenant, this one person, or this one need, it's costing you $27,000 a year to satisfy this 2 minutes because somebody was really vocal and you didn't want to piss them off. But if you can translate that into a dollar impact, it's enormously powerful, right? The messaging says, oh, I didn't know it was that expensive. I just wanted what I want, right? And then if you put it out in front of them and say, that's really helpful. I mean, it's not just really helpful. I mean, it's enormously helpful to be able to quantify the impacts. And it's a task that you can't do manually, right? So you have to find a tool, a mechanism to automate this. And there's over 30,000 tariff rates, right? So you don't need all of their tariff rates, but whatever is applicable for your given customer. And so we provide a tool, an ability to enter whatever tariff rate. There's a limited number, right? And here's a bullet list of some of the different aspects or components and how those tariffs are priced. Right, so sometimes based on per demand, consumption, there's ratchets, there's ranges, right? It goes on, but there's a finite number, and we provide the ability to provide all those pricing components into the model, and we can bang it against, compare it and correlate it to the energy demand. So it's a pretty powerful component of a tool. So define tariff rates, assign the meters, right? So what's the meter? What's driving, right? What is the tariff that's driving the cost components related to that meter, right? And you assign that, and it can be, sometimes it's different for a given meter within a building. It's certainly different across a portfolio of companies. Combining energy use data, greenhouse gas data. Is anybody in the room doing anything with greenhouse gas? Okay, we've got one hand. So it's going to become more and more prevalent, right? I don't know if you guys are hearing decarbonization, ESG, it's coming down the pipe. The SEC, right, that group that regulates all publicly traded companies in the United States, got a 490-page proposal out in the public to take today the ESG reporting requirements are basically written by lawyers who may never have stepped in the building, doesn't know, and it's just kind of a whitewash language to, oh yeah, there's impacts in the environment, right? Very high level. Proposal talks about, and it's supposed to be implemented in 2024, 2025 timeframe. They're going to be like, what are the initiatives you're doing? What is your expected ROI? What was your results? How much did you spend? That tracking tool, I don't know how they're going to implement the proposed regulation because most companies are not positioned to do that. right? But it's coming down the pipe. I don't think it'll be 2024 personally, but it's coming down the pipe, right? And so you can convert all the consumption to your greenhouse gas data, so we tie into the EPA site, and we can figure out by location exactly what your greenhouse gas emissions are being generated based on your sources. Pretty powerful stuff. Combining energy use data, greenhouse gas, calculate, track, and reporting performance. You know, first on just baseline. What is it? How much are you using? What's it driving? How is one versus the other, right? And so sometimes you may choose to do things in the evening when it's more friendly for pricing. Sometimes you may want to do it during the day when it's not, you know, so from an ESG perspective, solar might be is a cleaner source than at night where it may be cheaper, right? So every customer is going to have their own performance criteria on how they want to do that. So, you know, scope 1, scope 2, scope 3, I'm not going to go into it, but scope 3 is really the supply chain piece, and it's we're not even there. Scope 1 and 2 is what you're using directly. It's not important that we go in a lot of detail, but it's a very complex problem that's going to be coming down the pipeline. Okay, so meter data with equipment operation. What's going on with the equipment? Oh, the meter's spiking. Let me see what's going on with all the I/O in the facility. Every piece of information that's going on. Enormously powerful to be able to drill down. Let me figure out why this meter is operating at a certain level. What are all the pieces of equipment that are operating? What's the I/O points, right? Is that right? Okay, so KPIs, key performance, and what is the things that each facility wants to track? It's nice to be able to correlate performance, pull up variety of ways. There's an unlimited ways people want to track and report their KPIs. So energy data normalization, right? I talked a little bit about before, weather, building site, production factors, occupancy, revenue, unit productions. There's all kinds of ways, right? You got a factory that wasn't producing, it was shut down one day, right? You got a paper mill, uses an enormous amount of energy. Well, okay, you would expect the day where they were shut down on holiday not to correlate with the days that they've got production. Right, so baseline performance, whatever baseline you want to set, could be on your goals, it could be prior year. Support financial management. We talked a little bit about leveraging data and converting operational data into dollars. Right, so you have the ability to actually associate when this happens, it's either a cost per event or it could be a cost per unit of time, and automatically all that data is translated. You don't have to post, you have to have 37 Excel fields to try to calculate after the fact. Making use of data and results useful to operators, right? So this is a dashboard showing real-time data, right? So you can set up a dashboard for your customers and for yourself. But maybe you have a service organization that wants to look at one level of information. You want to share your information for a customer, and the operations guy wants a different dashboard than the general manager wants his monthly, quarterly number. So the flexibility to be able to present data in a manner for the audience member, right, is unique to the audience and the role of the individual. So making data and results useful to operators, right? The graphing and visualization is so important. Nobody wants to look at 4,000 or 400 lines of Excel data with 64 columns, right? Like, it's just, I do actually, but we won't go there. So other than the people like me that lean left when they walk, most people want to see the data visualized, right? So quickly, I can see what's going on. I want to know more information, so I'm going to take this little time span. I'm going to blow it up. Oh, by the way, now I want to do some real specific. Now I want to look at it, so I can export that data in a table, and then you can do your deep dive for a specific window if you want the time, right? So it allows you to stratify your data in whatever manner, whatever format you want, and go as deep as you want. All right, so then sometimes you want to export in a PDF file, right? Somebody just you want to send that out. Somebody wants an Excel file. Some of the programmers are going to want, they're going to want a JSON file because they're going to pull it into their machine learning and their Python, and they're going to do all their sophisticated analytics. our tool actually, you can actually run Python code in a Docker through our software and do machine learning at the edge, which is, we'll talk about that in 3 years, but it's like some people are doing some pretty exciting stuff in the world of machine learning, and, data is the source of that. All right, so getting there, there's 3 steps along the way, right? You have to acquire the data, right? So that's tapping the BAS. Sometimes there's no BAS, but you're going to tap in the meters or whatever the manner. Sometimes it's pulling in CSV files. It doesn't matter, right? And so you've got a variety of ways. We'll talk a little bit more about that in a minute. Harmonize the data, right? I want to be able to compare, right? And dirty data is a tough thing, right? And it's a phrase, right? Like, how do you deal with null values? How do you deal with change of values? Because some of these pieces of equipment have lots of gaps in the data, right? So our software has all that harmonization, a lot of that harmonization technology built in that allows you to just see the data in the manner that you want without having to go through line by line and figure out, like, why am I not seeing the data, right? Null values, zeros, change of values. You got to keep in mind, right? We've got building automation systems out there that were never intended to play friendly, right? They were expected to always be the highest level in the architecture, but now we're in a data-centric world. So now we need to release the data that's been collected in buildings for a decade or more in some buildings and just never really utilized. And a lot of the, a lot of the hardware manufacturers never really wanted to play nice. They wanted to create a captive customer. They wanted to control the data, and so that they could have a service business for going forward, right? So it's a unique challenge to harmonize that data, and getting a occupancy sensor to talk the same language with the heating system, right? So people are building all different types of sensors, all different types of equipment. You need to bring it in a world so that they all talk the same language, right? So you need to sort of Rosetta Stone approach to bringing it in so I can now work with this. And so time series data presents its own unique challenges. If you hear the word SQL and operational data, and it's going to be incongruent. You're going to run into some problems because time series data is a very, very unique challenge, very different than enterprise data. And then program customization, right? So being we have an extensible platform that you can create your own solution. Everybody can build their own secret sauce. There's lots of different applications out there. So we talked about this, right? So you're gonna pull in, we've got connectors that'll allow you to bring in BACnet, bring up the data from Niagara, Modbus, OPC UA, right? A whole variety of protocols. We have common connectors, and we have a connector framework that allows you, if you've got some obscure protocol and you need that, you can write a connector for that that's specific to your needs, right? We pull in weather data. You want to pull in production data, right? We have a full, APIs out, APIs in, right? Any of the IT people that use the word data lake, we'll talk about that in a minute, but you don't need to pull all the data in. You don't want to push all the data out, right? So so certain data belongs in its own sort of domain. We talked about production data. Maybe you just want to have a form people put in periodically. We're going to once a month load production data into these sites, and then we can use it. And then Project Haystack, right? That we talked about giving meaning to data. So tagging. Anyone heard of the term tagging or semantic modeling? All right, so few people, right? It's very critical. So you want to provide metadata so that you understand, like, this piece of equipment is located in this building on this floor. It's an air handling unit. This is this, right? So, because you really it's hard, right? You have to give meaning to the data. You see a number 64 in some field. You pull it out, right? Is it 64? What does 64 represent? Okay, first you got to know it's a temperature. Is it Fahrenheit? Is it Celsius? Is it intake? Is it exhaust, right? All that information is important because 64 by itself doesn't provide a lot of meaning. And so Project Haystack is a not-for-profit organization made up of lots of industry players to standardize semantic modeling, and we'll talk more about that in a minute. And then you've got all the results, the analysis, and the output and the reporting. So it's kind of we view it as a three-phase process. So now we're going to talk a little bit about independent data layer. I'm going to kind of probably go a little quicker. So there's this buzz about independent data layer. So the concept of an independent layer is you elevate data to its own independent entity. You pull it out of the device, you get it up, you get it to share without dependence on other applications. If you go back over the last couple of decades, a lot of data, even outside the built environment, was based on the application. And then you had to, that application had to decide how it wanted to play nice or not play so nice with other applications. So other applications, you generate the data, and then you need to use the data, right? So when you do tagging and you go into a building owner doesn't want to have to pay to have the data reunified or reloaded, re-onboarded every single time they add another application. So if you want to do, combine your lighting system with your scheduling, your enterprise scheduling software that you want to, hey, someone scheduled a conference room, we're going to turn the AC on 15 minutes before that conference room is scheduled. He doesn't want to have to pay for that twice. He wants to pay for that once. So the data should be available to all applications via a standard open interface, which is not the case today in all environments. So the increasingly important IDL, prop tech with operational data is going to become more and more prevalent. Duplicating the work to access the data, it's not cost effective, it's very time consuming. For some of us older folks, right, if you think about that, so the hierarchy of data used to be you had the applications were up at the top, sources, devices, and then the data was down below. And if you remember, like some of the HR folks back in the 80s and 90s, they took the organization chart and they flipped it upside down. I kind of think of the same analogy, right? So where they used to have the CEO and the customers were down below. I kind of view data the same way, right? Data is the most important piece of the equation. The fact that there's devices, the fact that there's applications. If you don't start with a data-centric world and mindset, it's a very, going forward is going to be, the challenge is going to continue to be difficult. But I think that the data piece is something that's not fully appreciated. So data is your building's most valuable asset. The data produced by a device is more valuable than the device itself. I'm sure there's a few OEMs out there that might disagree with that statement, but the fact that you pay X amount for a piece of hardware, the value of that device goes way beyond the short-term, near-term application of that piece of hardware. It's the data that it provides and what's going on. It's the lifeblood for understanding and making either cost savings or comfort, whatever your performance criteria is, right? So increased access to device data is empowering us to take advantage of it, critical to making buildings smarter, more efficient, more sustainable. Effective use of data creates better operational performance, workplace experiences. We're in an era where we can capture data from diverse sources and use it across multiple applications. But cost and complexity create friction. So we need to reduce those costs. Standardized semantic modeling reduces some of that friction, right? Buildings, systems produce a wealth of data, but most data produced by devices has poor descriptive information to define the meaning. So this is where semantic modeling and Project Haystack come into play to properly and consistently apply that. There's not historically been much standard approach to adding semantic information. Project Haystack's been around for 10 years, and the user base continues to grow. All right, so manual, labor-intensive process are required to add semantic definitions. There's a number of barriers, right? So data needs to have meaning to be useful. Don't just need to have access to the data, right? You can have lots of, there's folks that have hundreds or thousands of files that they can't talk, they can't get, it's a very painful effort. What am I going to do with this, right, is kind of the answer, right? So knowing which data to collect and use is key to unlocking value, and then the tagging provides interoperability between the data. All right, so the data challenge. Representing and normalizing, giving meaning across diverse data. All kinds of different things. We talked about the protocols, and then we need to unify that data. So acquiring data, all kinds of sources, defining meaning, tagging it. So Project Haystack is that you can see in the lower right, right? So these pieces are all electrical equipment, right? And they are equipment. And some of these are HVAC, some of this is lighting, some of this is a site meter, right? So providing that metadata is the basis for giving the data meaning. So once you format, provide the metadata, different source formats provide different amounts for descriptive data. There is no one standard I need to tag or I need to model my data, because some buildings, some applications need more data than others. So finding, the porridge is critical. What's the right sweet spot? So, and then we want to be able to pull in and export data in a variety of formats that allow programmers or operational folks to use that data or share that data. All right, so the variety of formats, what we need to know, your systems are really doing is assess the performance to drive action. What should I do with this information? What can I do to improve the performance of my building, whatever that is? Right? So Haystack is a standardized approach to make data work. So it addresses a challenge, right? Open source, everything is open source, all the technology is shared. If you are working with any kind of building data and you haven't been to Haystack website, I encourage you to go there. All right, so built-in meta tags, there's enormous amount of work that's been put into that organization over the last decade to provide some standardization. How many people have heard of Haystack in the room? Oh, that's a good indication, right? So 5 years ago, 3 years ago, there would have been fewer hands, right? You're going to hear more and more about this. And so for those technical, think of it as a markup language for data. Right. It works because the industry, HTML works because everyone agreed to do it, right? And if I go to a website, I can read that format, right? So Haystack is kind of the same way, right? You don't want to have to tag and kind of give meaning to your data in each individual application. You want to do it once. So some of the core concepts. So what is semantic modeling? The tagging, right? There's a couple of key components, right? So the vocabulary piece is I need to get some descriptive information so I know what's what, right? There's a taxonomy that defines hierarchy of relationships, and then ontology gets into the relationship of one item to another. By utilizing semantic tagging, operation data can effectively utilize enabling it. Right, so what it enables, the ability to use building data systems and other applications without being expert in the various systems to produce that data. That way, your machine learning folks, your Python guys, they can leverage and they can do their analysis across a diverse set of devices, making applications just work, right? So auto-generate digital twins by interpreting the metadata, control logic that can find all similar devices it should be applied to. So you want to do something on an air handling unit or whatever it may be. I want to know all the other devices that I ought to be using the same logic control, or I want to get the same information across the devices. A new generation of engineering tools that streamline implementation tasks and dramatically reduce costs. Right? So a lot of the challenge, right, is onboarding and the implementation. Wouldn't it be nice if we could reduce that time by an order of magnitude? So Project Haystack and some of these automated tools are going to allow dramatic reduction, right? So enabling a future where a push of a button can turn device data into true intelligence. Haystack's in over 40,000 buildings worldwide. I mentioned it's open source. I mentioned it's a not-for-profit organization. There's no cost to use it, so there's a lot of advantages. There's the ecosystem and the community using Haystack continues to grow. It is probably represents 85-90% of what practitioners are doing in real-world applications today. There's some other ontologies out there. There's some other applications, but Haystack is by far and away the leading modeling tool that's out there. All right, key takeaways. It's proven tens of thousands of applications. It's extensible. If you have a new device you want to bring on and you want to form a working group, the library and the knowledge in there continues to expand. It's lightweight for most small devices. It's not a heavy load. It's human readable. A lot of advantages. So, there's advantages across the entire value chain. There's values to the owner-operator, the facilities, the SI, the systems integrators, the OEMs. So we have a lot of OEMs now that are starting to put haystack tagging right in their hardware out of the box. So when it comes up, you don't have to do it right. So the earlier in the food chain we can get haystack tagging implemented, it's better, right? And so we all start talking the same language. So there's an exciting project going on right now. I lead on what's called the PI for the project. So the Department of Energy has identified haystack tagging as a key component, kind of the ESG decarbonization effort. So they're funding a 3-year project. We're 1 year into the project. And some of the main goals of the semantic modeling for the Masses project, first is validation, and then a public library and alignment with other ontologies. So I'm going to hit these. It's an enormously important movement that's going down. So validation. Today, there are different ways to interpret a haystack model, right? So if the building owner says, I want to tag something with haystack, I'm going to pay someone to do the tagging. Today, not every implementation is going to be exactly the same. But going forward, the goal is we're going to have a public library, and that we're going to have tools to say, okay, I want to follow ASHRAE guideline 36 for VAVs. So I got a whole spreadsheet, right? I got 3,000 of them across this portfolio. I want to find out which has been tagged compliant with guideline 36 needs. So we're going to have tool, and so there's a command line tool. It actually exists today, right? So the first year, that was the fundamental output of the first year's effort. So now we have a whole new technology called Zetto has been developed to, so anybody in the programming world or somebody wants to do a deep dive, follow up with me, but it'll allow you to run scripts, and you can just instantly run a whole database of equipment and say which ones have been tagged properly to follow these particular templates. And so when a building owner says, I want, state of Utah, anybody in Utah? Right? So now anything funded in the state of Utah has to be tagged, right? So Utah will have a repository, they'll have their specifications say, this is now the exact spec we need. So your systems integrator or contractor will go in there, and he's been paid to do haystack tagging against these templates, right? So this is what we need. Tool goes up, run through, okay, 60% meet it, these other 40% don't. Why? This is missing, maybe you need to do this. Look, iterate a couple of times, next thing you know, he's got 1,000 pieces of equipment that have been tagged and validated to meet the requirement. It's enormously powerful. Some fundamental technology has been developed to do that, and now they're working on tools to make it usable. So the public library will be a repository that'll be contributed by OEMs. It'll be contributions by folks like the ASHRAE. It'll be contributed maybe by state organizations, because you can't separate tagging from the application. So it's not like every air handling unit needs to be tagged the same way, because how people are using that or other pieces of equipment are different, right? So even something as simple as a thermostat, there's different applications on how you're going to use a thermostat, and if you want to do physics-based modeling, that's obviously a lot more complex need, and so these templates and those tagging needs are more in depth than what 95% of the applications are going to need. And then the alignment with other ontologies. So this technology, if you want to export to, the technology is going to allow you to export JSON and other formats. You want to figure out how does this go to an RDF model for those that are in the machine learning world. How does this relate to BRIC? So there's some work is going to be developing. So this kind of a unifying platform to be able to automatically, instead of just sort of looking at tables and say this is this, but literally export in a different manner. It's enormously powerful, super exciting. The folks are using it. So we have Haystack has their own conference. It's June 5 to 7 out in Nashville this year. We actually have a representative of the Department of Energy that's going to talk about how they view semantic modeling and the importance of what they're doing. And some pieces that I'm not even aware of is how the Department of Energy is thinking that semantic modeling is going to be what they refer to as an on-ramp for things that are outside of the spaces that we typically play. So they have even a bigger view than we do for semantic modeling, and I'm possibly. We have some of our own visions, but pieces of the vision. So it's going to be really interesting. And a number of the labs are going to be there presenting the stuff. So these are some of the corporate memberships. So we've got, like I mentioned, I sort of fulfill two hats. I've got CEO of SkyFoundry. We make SkySpark. I know that a lot of you are using it. And then I'm also a board member on Project Haystack. So with that, I would like to open up the floor to questions. And so if I can hear, I'll repeat the question and then I'll answer the question. There is a microphone floating somewhere. Okay. Who has some questions or comments they'd like to offer? Okay, great.
If your client is requesting you're integrating systems across a broad spectrum, and there you're not going to put them at a particular level where it's kind of a view only, would you be able to supply SOC reports and other security protocol reports for the networking to your system in order to protect maybe more sensitive systems?
The answer is yes, right? The short answer is yes, and in more detail. So our particular software, right, allows for every level of authorization, right? So you can authorize applications. So we start with multi-tenancy. So you could have your whole customer base that you're accessing, and each customer would have their own silo, have their own channel, right? So obviously one customer is not going to be able to access the other customer's information. A different role, you may have a individual at a customer that you want to allow to make changes, get in the coding and tweak things, right? So you can allow that. You might want people to be able to create views. So that at that particular level. We can even go, so you can allow, okay, nobody has access to this piece of equipment, right? So, there's a white building, right, in Washington. Maybe you don't want that occupancy sensor active for the guy that sits behind the big desk, right? So you can just shut that off to everybody, right? So we can go all the way down to the piece of equipment and a given point, by person, by role, by building, right? So at every level. That's overkill for vast majority of organizations, but full authorization. Our particular solution, SkySpark, is in virtually every branch of the military, including DoD black sites. So we offer a full on-prem solution in addition to being cloud-based. We've been evaluated, So everyone's like, oh, are you ISO certified with security? Well, that's part of the whole implementation, right? But ultimately, anybody who's taken a look, right? So we've been evaluated by IBM, Google, Microsoft, Apple, every branch of the military, right? We've never failed. We've never not passed a security review, right? And so there's some things around the government that kind of has validated us, if you would. But ultimately, it's the end application because you could implement our software in a manner that was insecure. Right? But there's no limitation on the security that we've come across that a qualified IT department couldn't implement. And we have some technology that allows that we go over. We do some WebSocket technology. We overlay over WebSockets so we can set a point-to-point, and then we're not that concerned. We can kind of bypass the firewalls, but it's adequate for the IT departments. So we don't have. So you can do a deployment and not get all caught up with every single firewall when the IT do. So and we have some white papers on that. Happy to go in more detail, but that's kind of the high-level security piece that we've got. Next question. I'm sure the third question will be over here.
Did you say the government's giving your company $83 million?
I didn't say that. So the funding is going to Project Haystack. So SkyFoundry is working in conjunction with some other players in the space, specifically Clockwork, Switch Automation. We've had a technical advisory group, 12 or 15 different companies that we've interviewed, brought in, right? So we are getting part of this benefit funding. So we receive part of that benefit funding for this project over 3 years.
And that's for just federal government, like for doing work for state entities and federal entities to kind of consolidate their data retrieval, like all of their points and stuff like that? Like, what is that going for, just out of curiosity?
Okay, so
That just seems like a lot of money.
So we're getting a subset of that money, so it's not this particular initiative. But so they see a need for validation and standardization. So today, how do we reduce the cost of onboarding and modeling data? Right, so this validation tool allows you to, one, the building owner or the person asking for something and the person out in the field to know exactly what the requirement is and to provide a tool set that will allow you to do it in a very fast and efficient manner. I mean, for those of you in the audience that have been involved in data tagging, you know it's not it's a big lift, right, sometimes to do that. So the ability to validate that, to know that I'm getting what I want. And
So they can only implement that in federal governments. Like private entities don't adhere to that standardization. So private entities can do whatever they want as far as labeling whatever data they want. So that works great for federal governments that they have the power or the control to enforce this. But how are they going to enforce it for private entities, which the majority of us already work in and deal with and stuff like that?
Excellent question. So let me clarify, because I hope I didn't leave that impression in the audience. So it's not a mandate. It's providing us tool set and a capability for some entity. It may be the government. It may be the state of Utah, right? I mean, the state of Utah uses SkySpark directly and indirectly pretty heavily, right? And so they mandate that it has to have it has to be tagged for energy analysis. They have some sort of standard practices, but it's not fully vetted, right? It varies, right? And so a contractor can also read this and say, okay, well, I got my own interpretation of how I'm doing this. So this idea of a public library will be there, and this isn't fully fleshed out. This is part of what's going to happen over the next 12 months or next year to figure out what exactly that public library consists of. But we envision thousands of templates up there. So if you were, what state are you with? Tennessee. Right? So Tennessee is going to have certain things that they want, right? They've got, every state has a particular governing body, NYSERDA in New York, right? And there's California, Tennessee. They all have some commission, some group that is trying to spearhead their energy management, right? And so it may come out of that group. It may come out of some other group. They may adopt some other standard. They may decide, we're just going to use guideline 36, right? That's what we want to do, and here's the things we want. So today, there's no talk of a requirement except a vehicle that somebody, whether it's an OEM, right? So you're going to put in a Siemens system. Well, Siemens will say, if you want to do X, Y, and Z, we're going to do this. If you want to do digital building and you want to end up doing some physics-based modeling, here's a tool. Go find this template, because I know I want to do this in my buildings, right? Let's say there's a university system and there are labs. And so universities have some interesting, very unique requirements for certain portions of their campus, right? So labs present a challenge. So you're not going to want that requirement across all buildings, but anybody who's got a lab that's, biology or health science, right? You'll say, okay, this is how I need to tag it. And you'll direct your contractor to go do, this is the requirement I want. So this isn't about mandating regulation. This is about providing tools, because the state of Utah, the state of Tennessee wants to be able to say, this is what we want our buildings to look like. And it might be an OEM. It might be somebody who has an application package, right? There may be a physics-based modeling tool. And it says, okay, if you're going to use our tool, this is the foundation that if you're tagged in this particular way, if you follow this template in the public library, right, and there could be a private component to that, which is not defined yet, you'll be able to run our tool because those have all the points, all the data we need to run our application. So it's not about specifically requiring. No entity is going to say you must do, there's no single requirement, right? But so the state of Tennessee says if you're going to get state funding, you need to follow this. Utah may have stricter requirements. New York may have even stricter requirements, right? California may say you got to meet every requirement, right? California gets a little crazy once in a while, but so I hope, did that clarify it? Okay, next question.
Just to clarify on the last bit, so what you're developing is an open source method for data tagging validation?
Yes.
Okay.
So today, so for those that know what an IDE, integrated development environment, right? So right now it exists as a command line tool. We're going to continue to build upon the tool set. The goal is actually to have an IDE for doing data tagging, right? Full integrated development, right? And so it's all today, right? So it's all in GitHub today. It's all open source. Everything that what Project Haystack does, it's open source. You'll be able to use the tools. You'll have access, right? So we've got at least a year, right, before the library is in a sort of an open format. And then we've got another year to sort of figure out some pieces like, for example, are we going to have an official validation? You're going to get as a contractor, I'm going to say, here's my address, here are the templates, here are the tagging requirements that I've met, push the button, here's the certification. I can then hand that to the commissioning agent and the commissioning agent says, good, right? You just saved a whole lot of work, right? So I got this, there's some errors here, right? So that's part of the goal, right? So some of the business process side, the requirements, do we hand this off the ASHRAE and let it go down a rabbit hole, or do we maintain some control, right? Some of those business pieces haven't been worked out. Does that answer your question? Okay.
So, say this is not a new construction job.
Can you hold it a little closer?
Yes, say this is not a new construction job. You have no power over the nomenclature of point naming from a specification standpoint, and you're coming in, you've identified a client who has good potential for the use of this product because you have valid data that you can determine by the level of access they have. You have the appropriate IO&Ms to be able to correlate what you're seeing. Do you have a way to create an independent correlation matrix using the existing naming convention to have it convert over towards whatever naming is expected by your preset rules that you want to employ for this, so that you don't have to create individual transfer points for that data up to like a SQL server for it to be used by the predefined rules? And then following up on that, the syntax for changing or customizing rules, is that an actual syntactical code you have to learn? Block wire, Boolean, how are the rules written so that if you did need to change data from the format it was received to a convention that was understandable by the program, you could write rules to go ahead and auto-convert that if that matrix didn't exist?
Something tells me you're not in the marketing department. So there was a whole lot there, right? So the answer is the rules, right? And obviously there's installed base, right? So actually, if you go to Project Haystack's website, we have three sort of, you can find data sets from three case studies, right? Real data that's been implemented. So we've actually applied the Zeto tool and say, let's see what it's got here. And we found, it's interesting, right? Like we just pull the data in, we run it through there, and like, oh, it doesn't meet like guideline 36. And I just use this as an example because that happens to be one of the foundation, we just started with, guideline 36 is one of the early templates that we wanted to say, right? Because guideline 36 is kind of out there, and how would that apply, right? So as far as like, has it been tagged, right? So this data that's on Project Haystack has already been tagged, it's in the building. Now you can go after the fact and say, does it meet the requirements? It doesn't. So now I just need to go back and fix the tagging in those particular pieces of equipment. So, okay, I'll try to answer your question, and I'm going to make sure I give you an opportunity. We're in booth 400, so if I don't fully answer your question, but I do, so the idea is that, like, in the stage 1, validate it. Does it meet the requirement? No. Stage 2 is, what's it missing, right? There's going to be subsequent, right, is suggestions. This might be this point, it might be this, right? So there's a continuum on where this technology is going to go. But for those of you who are programmers, it's based on inheritance, and so you've got a larger body, and so you're going to be able to drill down and get to the most specific application it meets. And it implies all the higher level, right? So there's maybe a VAV, and there's 6 classes and categories, and then in each category there are other types, right? So there's a lot of technology that's been built for this. It's not exactly a programming language, but it kind of is. It's not exactly a data model, but it kind of is. It's not exactly a schema language, but it kind of is. It's literally unique technology. Happy to go in further detail in terms of the specifics. Any other questions we have? How are we doing? We got 3 minutes.
So, great presentation. Thank you. Great job. And I think you touched on this thing, but maybe you can elaborate. We fully understand that government can mandate things and government has unlimited funding. But for a private institution, a private university, hospital, do you have a model for return on investment? What is my payback? Because the CFO of that organization is going to say, okay, I'm going to spend so much time, money, effort. What's my payback? Is it 5 years, 10 years, 2 years?
Okay, phenomenal question, right? So I'm a recovering engineer, but I also did a lot of consulting, a company called Booz Allen, right? And so everything we had to have, it had to be economics-based, right? So economics is the answer for all the business people, right? Some level of economics need to be applied. So the short answer is there are data points out there. So Lawrence Berkeley National Lab has done some fault detection and some other advanced analysis. I will say that almost all of it is flawed because almost all the studies are 1 year of what did I get in the first year, what did I get in the second year, and I haven't seen any data that goes beyond the second year in public domain. So GSA Link, anyone familiar with GSA Link, right? Largest analytic project in the world, we believe. They've been using our software for a decade. Their level of savings is approaching $100 million since they've implemented the software. And every year, it's an ogre. They're peeling another layer. They're getting smarter, right? Because data is actionable information. So what we find is people can put the software in, and if you don't fix the problem, you're not getting any ROI, right? So there is no one answer. So how big of an effort are you going to do? But I will tell you, right, there's enough information that with a little bit of, if you're not a complete skepticism and you have a vested interest in just denying it, there is so much data out there that it is an obvious ROI. Problem is the incentives are not aligned, right? So now I'm going to get a little philosophical, right? So 90% of the buildings out there are transactional in nature, meaning not an owner-operator. So 90% of the buildings are their buildings are valued on NOP, right? Net operating profit. And, we have this thing called triple net, and the energy price I get to offload this. So if I'm a transactional and I own a building, The hook's getting out, I think, so I'm going to try to answer this quick. So if I own a building, anything that affects my NOP lowers my exit value in my business. So there's some disincentives for certain people, but the owner-operator, right? So state of California, every university has our software. University of California, half the universities. University of Michigan, University of Florida, Notre Dame. There's UC Davis. Go to our website. You can see, University of British Columbia. University of British Columbia, beautiful example, right? We did this, and then they did this, and then they did this, and then they did this. This is a journey. It's not like I put the software in, hit go, and say, okay, now the till is I'm going to hear the cash register start ringing up. So unless you take the action for what the data shares, so the GSA link over 100 buildings, they collect 90 million data points a day. They have hundreds of billions of data points. They've never thrown a piece of data away, right? They turned the system on and then went, holy cow, right? For those of the electrical engineers, right, or people who understand signal to noise ratio, and they had so much information. They shut the project down, and of course the government can afford to do this. They shut the project down and said, we need a whole process. They spent months developing a process to handle and prioritize all this actionable information because they weren't prepared for, wow, where do we even begin? So they spent months developing a prioritization and action plan to address the information they were provided. Then they turned the system back on. It's a big challenge, right? But I can tell you it's an enormous opportunity. Enormous opportunity. I think that unless there's one short question, no, I'm over my time. So thank you for participating. Happy to answer any specific questions. 400. I'll stay around here for until people leave if they want to grab a business card or ask me questions offline. Thank you so much.